Lesson 2 of Chapter 3, Adding and Subtracting Linear Expressions. So a linear expression is an algebraic expression in which the exponent of the variable is 1. So let's take a look at linear versus nonlinear expressions. So if I have negative 4x, that's linear. These are all examples of linear because if you notice, the variable doesn't have a power shown. It really does have a power because there's an invisible 1 there. I could put a 1, I could put a power, above all of these exponents, but it's just 1. So if your exponent is 1, it doesn't have to be written. It's considered invisible, but it's really there. Whereas non-linear expressions, that's when our exponent is something other than 1. So those are all non-linear. We're not going to deal with that this section or this lesson. We're just adding and subtracting linear expressions. So let's see, how do we do that? Okay, there's a few ways to do it. So when we're adding, let's look at this first box, linear expressions. We're going to stack them vertically, lining up the like terms, and then just combine those like terms. So let me show you what I mean. You'll notice a linear expression is broken up or divided by its parentheses. So that's one linear expression, this is another, and we know that they're being added because what's in between those parentheses. Don't look at each individual one, look between it where I highlighted yellow there. So these are each linear expressions. We have the linear expression x minus 2, and then another one, 3x plus 8. We're going to stack them vertically. Vertically means on top of each other. Just like you would add a normal like 2 3-digit number, we would stack them on top of each other. So I'm going to write x minus 2 plus, and then I have 3x plus 8. Now notice, I'm lining up like terms. Negative 2 and a positive 8, those are my constants, they are alike. And then my x and 3x, those are my variables, and they are alike. So now what we're going to do is we're going to combine them as we go down. So we're looking vertical here. What's negative 2 and a positive 8 give you? Well, they're different signs, so we're going to subtract them. 8 minus 2 is 6. Take the sign of the larger number. It's going to be positive, and we're always going to put that sign there. Now, what does a x and a 3x give you? So I have 3x and I add x to it. That should give us 4x. If there's not a a coefficient here in front of the x, remember it's invisible. Our invisible number is always 1. So keep your variable. 1 plus 3 is 4. So that's our answer, 4x plus 6. Remember, you should be getting an expression. So that's how we added linear expressions. So now I want it to be your turn. I want you to stack, combine, and then when you're done, press play and we'll go over it. So pause this and try it on your own. All right, welcome back. Hopefully you were able to stack them and get an answer, and that's in your box down here. Let's go over maybe what you did. So I'm going to write my first expression. I notice we're still adding. So I'm going to write negative 8z plus 4. So my first step is to stack them. Minus 7. Now the reason we stack them is to kind of line up our like terms. Do you have to stack them? No, it's just a way to visually see what we should be combining. You're combining your constants and your variables, and we're looking vertical, we're looking up and down. So it's just a nice way to easily gather your like terms. So now I have positive 4 and a negative 7. They're different signs, so you should have subtracted them. 7 minus 4 should have given you 3. And take the sign of the larger number, so it should be a negative 3. Next, a negative 8z and a positive 8z. Different signs, we would subtract them. What does 8 minus 8 give you? 0z. Now, if I have 0 and I multiply it by any number, no matter what z is, this will always give us 0. So if you put 0z minus 3, you're correct. But do you need that 0z there? No, you could just say your answer is negative 3. However, if you had this, that is also correct. I'll take it. So again, like I was saying, you don't have to stack. I just think it's the easiest way to visually see what is alike. We line up our like terms. Some people like to just, quickly go, all right, this and this we're combining. They have different signs. I'm going to subtract, and then this and this. And they kind of just work horizontally across. And that's fine if you prefer that method. I'm not saying you have to stack. This is just a way that I find it easier, a way that I want to guide you to practice. If you need guidance or a way to do it, I would prefer this method here. So now what happens, let's go over to what if we're subtracting linear expressions. So I'm going to move over to the right. So subtracting linear expressions, a little bit different. But I want you to think about how we subtracted in the past few chapters. When we subtract, we're really adding the opposite. So we're going to apply our keep, change, change here. But this is where it can get really tricky. Okay, and again, this is just one way I'm showing you. I'll show you another way to remember it. But one method is our keep, change, change. We're going to keep our first expression exactly the same. So remember, we have two expressions, and they're separated by a subtraction sign, which is why we know it's subtraction. We're going to keep this entire expression. So I'll keep it as m minus 3. We're going to change our subtraction in the middle to addition. And then we're going to change everything inside of our second expression. So this negative m is going to become positive, and this plus 12 is going to become minus or negative 12. Now we're back to adding linear expressions. So we're going to go back to our stacking and combining like terms. So I have my first, and I'm going to line up its like terms. So I have an m minus 12. Now let's combine our like terms. Negative 3 and a negative 12, they're the same signs. I should keep the sign and add them. M plus m, remember they have that invisible 1 in front of them. So 1m plus 1m, how many total m's do you have? 2m. And we're done because you can't combine that any further. So our answer is 2m minus 15. So this is the first method or way to do it. There is another way that some people like to do it instead of my kind of keep, change, change. I'm just trying to keep it consistent with what we've been doing in chapters 1 and 2, and if that's something you like. Some people like to think of this, and I'm going to show you it because some people like to see this visual and way of doing it. So if you have room or another scrap piece of paper, you might want to write like method 2. The other one was method 1. If you want to show this way as well, because this might be something you like, or maybe you want to watch it first and then replay it and write it down the second time. Some people like to think of this as a negative. They put a 1 in front of that second expression, and they think of this as distributing a negative 1. So what happens is you keep the first, just like we would. But now, what happens when I distribute a negative 1 into each term, right? It's like the distributive property. This I would change to plus, but now everything changes over here. What's negative 1 times a negative m? Remember, there's really a 1 here. So negative 1 times negative 1 gives me a positive 1m, or just m. And then what's negative 1 times a positive 12? That gives me a negative 12. So we're back to where we were when I did keep, change, change. Some people like to see it this way, but now I have addition in the middle. I'm going to stack if you want to stack, or just combine your like terms. 1m plus 1m gives me 2m. Negative 3, negative 12, same signs I add, keep that same sign. We still get that same answer, as you should. Remember, no matter what method, you can do it one way or another way, you should always still get the same answer then. Okay?